So this is section 4.4. It's all about inequalities, and what it really boils down to is the same kind of number line we've been talking about with quadratic functions, but now we're going to do higher level polynomials, higher degree, and also rational inequalities. So if you look at the examples I have, I'm going to do a couple of each type and then leave a few blank for you to try. So let's do the first one together. So if I look at this x cubed plus 8x squared, first of all, you want to notice that everything's tied by addition on this one. In order to use a number line, we need to make sure we do multiplication and division only, which means we're going to factor, we're going to get common denominators, we're going to do all the algebra skills we've been practicing. So the first one, if I do the GCF and I factor out the x squared, I get this. Okay, and then if I go straight to my number line, here's what's happening. I have negative 8 on the number line, and I have 0 on the number line. Now remember, the numbers you're going to pick are going to be numbers a little bit left of negative 8, so negative 9 is fine, something in between negative 8 and 0, and then something to the right of 0. Alright, now the numbers I choose, I'm going to plug those into each factor. So if I take negative 9 and plug it into x squared, I get a positive value. And then if I take negative 9 and I plug it into x minus 8, I get a negative value. And then I have a positive times a negative makes an overall sign of a negative. And let's do the same thing with negative 1. When I plug it into x squared, it's positive. When I plug it into x plus 8, also positive. Two positives make another positive. Okay, then I'm going to go to a 0, and I'm going to plug in 1. 1 squared is positive. 1 plus 8 is positive. Two positives make a positive. Okay, so now I want you to tie a few things together for me. First of all, it doesn't follow the pattern of a quadratic. Most of our quadratics go plus minus plus, or the reverse. So this one goes minus plus plus. Now think about all the graphing we've talked about. If I made you graph this thing, so just kind of picture this out to the side. You don't have to do this, but it's good to make a connection between the sections. This thing would be an overall x cubed. It would have zeros at 0 and negative 8. Overall end behavior would be starting down here, ending up here. It would cross through negative 8 and then touch at 0. Okay, so I'm going to look at the graph in relation to our number line. To the left of negative 8, it's negative. In between negative 8 and 0, it's positive. And then after 0, it stays positive again. So there it goes, negative plus plus. And that's based on the multiplicity. So think about this. If it's x squared, we know that that should just touch, which means it stays positive, touches, and goes positive once again. So hopefully that number line and then the graphical representation makes sense together. Okay, now let's put it together for the final answer. We want to know, when is this cubic function less than 0? In other words, when is it negative? So now I look at my graph or the number line, and hopefully we can see that it's between negative infinity and negative 8. Okay, now take a peek at the next example. I want you guys to try that one on your own, and before you do it, make sure you move the negative 15x squared over and then start your factoring. Now take a look at number 3. It's a little bit different. Now we're talking about a rational function. So if you had to go into all the details of a rational function, you'd talk about the asymptotes and the x-intercepts. Well, let's just do this one with a straight number line. If you look at the numerator, it's already factored, and it's factored so it's x minus 3 times x plus 2. So we have multiplication on the top. And then divided by this x minus 1 on the bottom. So this whole thing is multiplication and division, which means I can go right to my number line. Alright, now you put all the numbers on the number line. So negative 2 from the numerator, 1 from the denominator, and 3 from the numerator. And then the numbers we're going to pick, a little bit left, somewhere in between, and a little bit right. Okay, now if I go through all the pluses and minuses, if I take negative 3, and you're going to plug it into all 3 spots, it would go negative, negative, over negative. And then 3 negatives make an overall sign of a negative. If I take 0 and I do the same thing, negative, positive, over a negative, that's a positive. Okay, same thing with 2. And then finally with 3. Okay, now let's take a look at our function. I want to know, when is it less than or equal to 0? So I want the negatives. So I'm going to look at my number line and I'm going to say from negative infinity to negative 2, closed bracket because this says equal to in it. All right, union, and then I'm going to go 1 with a parenthesis. I'll explain that in a minute. Up to, well, not infinity, sorry, up to 3. It should be a 3, sorry about that. Okay, now, this guy here has a parenthesis on it because x minus 1 is in the denominator, which means it can never equal 0. So even though it has a square bracket because of the equal, because it's in the denominator, we have to have a round parenthesis. All right, we have 2 more examples to go over. Now what I'm going to do is I'm going to do number 4, and then I'll have you guys try number 5 on your own. Okay, so 4 and 5, both of them actually, if you look at them, they each have something on the right, which means I have to move it over to the left. And then everything will be tied by addition and subtraction, which for a number line is no good. We need multiplication and division only. So if I take a look at number 4, if I just kind of start working out some of the algebra, all right, I'm going to have the left side stay the same, move the 7 over, and I see it's all addition and subtraction. So now what I need to do is I need to get a common denominator. Now a big no-no, whatever you need to do, no. Make sure you do not clear the denominator. All right, for inequalities less than greater thans, we cannot clear the denominator. You can only do that with equalities or equations. So make sure on these we have to get a common denominator. And if I look at this, my common denominator is x. So if I go over here in red and I just started kind of tacking on x's to things, here's what I have. I have x squared plus 12 minus 7x on the top all over x. Now, even though it's kind of rearranged funny, hopefully you can see that the numerator is going to factor to x minus 4, x minus 3 all over x. All right, now I'm all set for that number line. So here we go. Number line, I'm going to have 0, 3, and 4. I'm going to skip a couple steps on this, but I think we're kind of probably getting the hang of these after a few of these now. And the pattern would go like this. All right, and on this one I want the negatives, so I want everything from negative infinity to 0, and then 3 to 4. Now notice these all have round parentheses on them because this starts out with a less than, not a less than or equal to. So there should not be a single square bracket in the whole thing. All right, now you guys try number 5. Move over the 3 over x plus 1 first, get a common denominator, then go into your number line.